Are you tired of System D, but not emotionally prepared to watch Gen 2 compile Firefox for 6 hours? Tired of GNU utils, but not ready to become that guy explaining why sed peaked in 1993? Tired of glibc, but don't want to commit to Alpine Linux as a glorified bootloader for Minecraft? Enter Chimera Linux. No glibc, no GCC, no System D. Just a lightweight Linux distro built entirely out of refusals. What's up guys, my name is Tony, and today I'm going to give you a quick and painless guide on installing Chimera Linux. Chimera Linux is a general purpose Linux distro that rejects common defaults such as System D, glibc, and GCC. Instead, it uses the Chimera utils, which is a combo of FreeBSD core utils, LLVM over GCC, and Musl libc over glibc. There are several benefits to these, which we'll cover as we go through the installation process, but for now, let's jump right into it. So we are going to head over to chimeralinux.org and click the downloads button here, and we'll get the latest images here. Now for me, I am on x86 tech here, so I'll be using Chimera Linux x86-64, and we're going to use the live base ISO here, so we'll grab that. So here is the boot menu, and we're going to jump into that 6.18 generic kernel, and there we go. We see the Chimera login screen. So I'm going to log into root here. It's going to be root. The password is going to be Chimera, and there we are. So we'll double the font here with set font -D, and then I'm going to immediately SSH to this ISO here, and I will see you shortly. So I'm going to be using this Chimera Linux installation documentation and referencing it throughout this video. I will put a link to this documentation below the subscribe button, and the first thing we're going to do is partition the disks. So as we see, this documentation does encourage CF disk, which we're going to use. We're going to scroll down to the UEFI section because that's the most important part for us. It's just telling us to ensure that we set the partition label to the GPT. So that being said, let's go ahead and head over to the ISO and create these partitions. As we do a sanity check here, we do have dev VDA as our label. So let's do CF disk dev VDA and set GPT for the label. Now we're going to do our usual 1 GB boot partition here. Type is going to be an EFI system. We'll go down, create a new partition, and that's going to be a 4 GB swap partition with the type being Linux swap. And for the last partition, we can just hit enter twice here to allocate the remainder of the space to our root file system, and we are good to go. So let's head over to write, hit enter, type yes to write to the partition, enter on that, and then quit. And now we see we've got those 3 partitions. All right, so I'll go to the file system section here, and we do see we are prompted to make an ext4 file system. It does support XFS, but we're not going to talk about that because that's out of scope for this video. It tells us about the vfat partition for the FAT32 file system as well, and the swap here. So pretty good documentation here. Let's go ahead and apply that. So let's run mkfs.ext4 dev vda3, and that's going to put that ext4 file system on our root partition. Now we're going to do mkfs.fat-f32. It's going to be dev vda1. So we've created that FAT32 file system here. And for the swap, we're going to do mkswap dev vda2, and there we go. So we can clear that with Control L here. So the next portion here discusses mounting the file systems. As we scroll down to the UEFI section here for the mounted file systems, this is what we are directed to do. And we're going to follow this more or less, except we're not going to be using media root as our prefix. We're just going to use /mnt. Now let's jump right into that. So we'll do mount dev vda3, put that right on mnt here. And if we run man on mount, there is a make dir option here for -m, and this is very useful for us. It means we can do mount -m dev vda1 on mnt boot EFI, and that's going to automatically create the /boot/EFI directory for us while mounting it. And there we go. And the last thing we want to do is swap on dev vda2 and run an lsblk sanity check. As we see, we've got VDA1 mounted to boot EFI. We've got VDA2 with the swap turned on, and we've got VDA3 mounted on mount, which means we are ready to install Chimera Linux. All right, so we see the installation handbook here offering us 2 choices. We've got the local installation, or we've got the network installation. Now, some of you may be saying, hey, the local installation is probably better, probably going to be faster, and there's credit to that argument. But for me, I'm going to go with the network installation because it's going to give me up-to-date packages, and it's going to skip me one step of updating my packages when I boot into Chimera Linux. So we're just going to run Chimera Bootstrap onto our mount point, which is MNT. So we'll do Chimera Bootstrap onto /MNT, and I'm going to let that run, and I will see you shortly. All right, so that worked out here, and we are ready to perform the post installation steps. So let's go ahead and take a look at those here. We've got creating a user, setting a host name, setting your time zone, setting the hardware clock, enable system logging. So we're gonna do all that here. Let's start with the user. Let's go ahead and hop into a shell here with Chimera Root. And we are in that shell here. So we are going to create a user. We're going to do user add -m to make the home directory -g wheel to add us to the wheel group here. So we can run do as, and then we are going to name that user Tony. So we'll set a password for Tony here, and we're in there. Let's also set a password for root. We've got passwords for both root and Tony here. Let's test to see if Tony works here. So I am Tony here, and I am in the wheel group. So let's test do as, and there we go. So we have access to do as. We are as Tony. Let's get back into root here. Move on to the next step here. So we already did bootstrap the system here. Now it's time to install the Linux kernel. So we are rooted into the system already. So we'll do apk add Linux stable. It's going to be about 682 megabytes. Let's get that going here. And there we go. Got the Linux image, the initRD image here. So we are good to move on to the next step. We're going to talk about package management here. On Chimera Linux, we're using APK, just a very minimal package manager that Alpine uses as well. So we'll do APK search Vim, for example, and we do see Vim 9 is available and Neovim 12 is available. Incredible. So let's actually install Vim and Neovim at the same time here. So we'll do APK add Neovim and Vim, and we'll consent to both of these. Incredible. So we have access to Neovim and we have access to Vim. Perfect. So now that we have Vim here, we can set our host name. So let's run Vim on etc hostname. And we're going to set that to Chimera BTW because we're using Chimera, by the way. Save and quit that file. And let's go ahead and set our time zone here. It's going to be the usual ln-sf command. We'll do ln-sf user share zone info. And for me, in my situation, I am in America, Los Angeles. It's going to be etc local time. There we go. So we're going to get our hardware clock set up, and this is going to break away from the systemd method, and we're just going to echo local time into etc hardware clock. So we'll do echo local time etc hw clock. So let's take a look at the dinitctl commands that are going to be starting when we reboot here. So we've got elognd, cron, dbus, udev, and the T2i here. We want to add DHCPD to this, and then we're pretty much ready to go. And we want to do this from the rooted environment just so that we can get it fresh when we reboot. So we'll do an apk list DHCPCD. We do see it's installed there. We do see it is installed in userlib dinit.d. So we're just going to simply ln-sf user lib dinit.d DHCPCD. And we're going to symlink that to etc dinit.d boot.d DHCPCD. And that is the equivalent of running dinitctl enable. So let's actually get this fstab situated, but let's do it from outside of root here. So let's just type exit here. Let's run gen fstab-u on MNT. And there, as you see, we've got our UUIDs of our 3 partitions. So we're going to echo those into MNT etc fstab. We'll root back into the system here. And there we go. We see the fstab is set up here. Perfect. So before I reboot here, I'm going to install Zig, and I do want the version 16 of Zig. So I'm going to make a directory called op. And then what I'm going to do is wget Zig here. It's going to be this version 16 x86-64 Linux link. What I'm going to do right now is cd into temp. I'm going to do an apk add wget to install wget. All right. So we can clear that. And now I'm going to run a wget on that Zig URL. And there we go. Got that tarball here. So we've got tar installed. So I'm going to tar xf Zig. So we've untarred Zig here. So now I'm going to move that Zig binary to opt Zig here, and I will symlink opt Zig Zig to user local bin Zig. Now I can do Zig version, and there we go. We've got Zig installed. So the reason I had to do that manually was because if we do an apk search Zig, we get nothing. So Zig's not actually in the Chimera repo, and we're gonna need Zig today to compile OXWM from source. Speaking of that, let's grab a couple things we need git. We don't have that. So we'll do apk add git. All right. And I'm going to run apk search on xorg, and we do have access to xserver xorg version 21 here. So we'll go ahead and do apk add xserver xorg here. going to be a 500 megabyte download. So I'm going to run that and install that. All right, so we got an Xorg here. And now it's time to actually clone and build OXWM from source here. So OXWM is a window manager that I built in Zig here. And as of the time of this video, it has been updated to support Zig version 16. So take a look at that here. And I'm going to be adding some documentation to the README here for Chimera Linux. But for now, let's go ahead and clone this repository here. Let's swap into Tony here. And we are in the home directory for Tony now. So let's run git clone https github.com/tonybanter/oxwm. And there we go. So we can cd into OXWM and we see we've got the source code for OXWM right here. So if we open up this build.zig file here, we do see a couple of dependencies. We have X11, Xinorama, XFT, and font config here. So we're gonna need the development packages of these dependencies. We'll do an APK search libx devil here. We got a ton of them here. So what we're gonna do is grab libx11 devil, libxinorama devil, libxft devil, and font config devil. We got to run that as do as, and there we go. We got 42 megabytes of packages here. Let's run that install here, and that should be good. In theory, we should be able to run zig build -d optimize equals release small. And there we go. So let's actually make an xinitrc here. We'll do neovim xinitrc. I'm literally just going to do exec home Tony OXWM. It's going to be zig out bin OXWM. And I'm also going to set my screen resolution to 1920 by 1080. Is install Alacritty. So let's actually clone it from source here. Git clone github.com Alacritty. We'll cd into Alacritty here. So Alacritty is a Rust project here. So we're going to need cargo. So let's do as apk add cargo. Perfect. And then one more package we're going to need here is package conf. So let's do an apk search pkg conf, and there it is. So we'll grab that. Do as apk add package conf, and then we'll do the cargo build release here. And we want to be hitting the internet at compile time. That is exactly the right time to hit the internet. And there we go, 32 seconds. Just totally chill to make a terminal. So now we'll do a do as cp target release Alacritty. We're going to copy that into user bin Alacritty. And there we go. All right. And one more thing we need to do before heading over to the post install configuration is install a bootloader. Now, of course, we are GNU free in some aspect, but we can't just say GNU is evil for everything. We're actually going to leverage something called grub, which may or may not have been made by GNU. I'll let you determine that. But to do so, we're going to use apk add, and we're going to grab this EFI version of it. So we're going to install grub here. And then to actually install grub on our system, let's do grub install dev VDA. It's going to automatically determine our x86 64 EFI due to EFI boot manager. And then we will do grub-mk config-o boot grub.cfg to make that config file. And as always, we can ignore this disable OS prober error because we're not dual booting. All right, so we've got our first reboot here. Let's hit enter here and we're booted in, which is a good sign here. All right, so let's go ahead and chmod plus x.xinitrc to make sure it's executable. And we can clear that and just run start x here. And there we go. Beautiful. We see the OXWM loaded up here. This is the default config, and I've got ability to use super 1, 2, 3, etc. to switch tags. So let's open up a terminal here with super enter, and there's Alacritty. Perfect. All right, so let's make a quick to-do list here. It's going to be an MD file here. So the first thing I want to do, install a browser here. And then we want to install a nerd font. And then we also want to grab a wallpaper. We also want to grab the Neovim and Alacritty Dotfiles to make this consistent. And then we will do a Musl versus glibc demo here to kind of explain what that is and show the benefits of Musl here. But yeah, so far so good. We are on the 7.0.9 generic Linux kernel, which is looking good. So let's save this here and let's just start doing this. All right, so let's open up a new terminal here and let's do apk search browser. I'm going to go with the Qt browser here. I do like that browser, so feel free to go for your own browser. But for me, I'm going to do as apk add Qt browser. So that's going to be a 670 megabyte download. Let's let that run here. All right, we've got Qt browser. We don't actually have dmenu, so let's go ahead and get that as well. Let's just do a git clone git.sucklist.org/dmenu. and we'll cd into D menu and just run do as make install. And now we should be able to run ls and pipe that into D menu here. And there we go. So we've got D menu, which means the default bind in OXWM will be Alt D to open up a D menu prompt. And there it is, vertical. Now let's open up a Qt browser here and that tiled there. Let's go ahead and close this terminal for now. And I apologize for the flashbang, but we've got the browser, cross that off the list. Now we want to grab a nerd font here. So I'm going to go back over to the browser here and open up DuckDuckGo here. Search for iosevka nerd font. We'll click downloads here. We'll just search this page for iosevka and there it is right there. So we'll download this and we're going to save it to that downloads directory. And it is a zip file here. So let's let that one rip. That is a 350 megabyte file, but okay, it's done. And while we're here, let's grab a wallpaper. Now, for me personally, I'm going to go to github.com, Tony Banter's Debian, by the way, because I have a wallpaper right here. I'm going to download this. It is the legendary Luke Smith wallpaper. So let's download that raw file here, save that. We can open up a terminal here and close that browser out. Let's actually install that nerd font here. So we'll do cd downloads. And let's go ahead and just unzip this here. So let's see if we have unzip, and we don't have unzip here. We'll do a do as apk add unzip. And there we go. And clear that. Let's make a directory here called local share fonts here with mkdir-p to specify recursively. And we can actually run man on unzip here. We see -d is going to be the directory in which we extract the file to. So let's run unzip on iosevka.zip. Let's make the destination local share fonts. And we are unzipping that. We can clear that for now. And we will do an fc-cache space -fv to force it. We can clear that. And now we can do fc list and we can pipe that into grep and then grep iosevka. We got to make sure it's case sensitive here. But we see we've got iosevka in our font list, which is perfect. So we've installed a nerd font. Let's go ahead and cross that off the list. And we got a wallpaper. We just haven't set it up yet. Let's actually get our Dotfiles for Alacritty first because we can leverage the font we just downloaded. All right, we'll go back to home here and then we're going to clone my Alacritty config and we're just going to put that into .config/Alacritty. And there we go. All right, so we'll quit Alacritty and open it. And there we go. We've got our Alacritty iosevka nerd font and the Tokyo Night theme. Perfect. So now we can grab our Neovim .files and I'm going to grab that like so. Just going to put that straight into .config nvim here. And now I'll install these plugins as I always do here. And there we go, Neovim 12. So we've got Neovim, got Alacritty, got Telescope, perfect. And cross that off the list. So now we just need a set of wallpaper and then cover Musl and glibc. Now before I do that, I am gonna do one more thing here. I'm gonna grab my OXWM .files and just to make things look a little bit cleaner. So for the static block here, instead of lavender, and what we'll do here, let's actually just go to this whole section and run an S to replace lavender with sep. And there we go. A little tiny change, but you should be able to see it now. Last thing we wanna do is change the font to iosevka nerd font. And there we go. So we're actually gonna have to kill OXWM and restart here since the font wasn't cached when I initially loaded it, which is fine. Let's just go ahead and do that here. We'll close this, close that, close OXWM, start X, and there we go. So we've got that to-do list open here, and we can actually mark OXWM.files. That's complete. We got the wallpaper, and we need to set it up now. So to set the wallpaper up, as you can see, I usually run X wallpaper, but if we take a look here, that package doesn't exist on APK. But what does exist is image magic, which is even more minimal than X wallpaper. So we'll do a do as apk add image magic, and there we go. Now that we've done that, we should be able to run display-window root. I believe it's going to be in downloads and it's wall1.jpg. And there we go. We've got the obligatory Luke Smith wallpaper here. And yeah, looking like a pretty clean Chimera Linux setup. So let's go ahead and go over Musl here versus glibc and explain what it does and what the differences is. And we'll show with an example and then we'll head out of here. All right, so we're going to talk about Musl here. So Musl is a C standard library, same job as glibc, the GNU C library that ships on most distros. Every time you call printf or malloc or open, something has to actually implement that. On legacy distros such as Arch, Debian, Fedora, etc., that's going to be glibc. On Alpine and Chimera and some other iterations of Void, etc., it's going to be on Musl. So the pitch for Musl is simple. It's small, the source is actually readable, and unlike glibc, it was designed from day one to support static linking properly. The last part is the entire reason I care about it. So let's take a look at our Clang version here, and we see it is Clang version 22.1.4, and the target is Chimera Linux Musl. So let's do a demo here. Let's go into this Musl demo directory, and let's make a file called hello.c, and we're going to include standard.io.h. All right, so let's just do a simple hello world here. We'll do int main, we'll take in no arguments. We'll print a couple statements here and we'll return 0. So now if we just quit this here and let's go ahead and run clang hello.c, and this is going to be the dynamically linked version. We can see if we run ldd on hello.dyn and we run ls-lh on hello-dyn. First thing is we look at LDD and it depends directly on Musl x84_64.so. So on Musl, the dynamic linker and libc are actually the same file. So here we go. On glibc, those are actually two separate things. And we see the binary is about 7.4 kilobytes. And that's important. We'll benchmark that later. Now let's build a static version here. We'll just do a clang-static hello.c, and the output's going to be hello static. Now we do a LDD on hello static, and we see it's not a valid dynamic program, so it's not even dynamically linked. And if we do an ls-lh on hello static, we do see it's 140 kilobytes file. And we'll do a comparison here. I'll jump over to an arch VM here. I'm going to make the same file here. So I've made the same file here. So I'll run gcc hello.c, and we're going to do an output to hello dynamic glibc. We'll do the same thing with the static flag. So now what I can do is a comparison. So now we see the static glibc version is 850 kilobytes. So if we do 850 divided by 150, we have, it's about 5.6 times the size. So we also see the same thing here. We LDD on the dynamic version. And as I said earlier, we have two different files for the linker and the glibc file. So again, 850 kilobytes as a static binary compared to 140 kilobytes. And that's going to be a big deal for us. So that's pretty cool. To really hone in, one of the biggest things for me on Musl, other than the fact that I can statically link binaries, it is the auditability of the code. So let's take a look at something simple such as git opt. So we're going to go to gitopt.c, and that is in Musl here. We got 100 lines, pretty easy to audit. So if we actually look at the gitopt function here, we can really kind of see what's going on here. It's parsing argv, and we're going to be handling some edge cases. And it looks like here we're handling the colon case for required arguments. And then a little bit further down, we're just returning. And that's it. That's the whole thing. Top to bottom. I mean, it's really a 100-line file. So if we do the same thing on glibc, let's go to gitopt.c. And it's an 800-line file. And it's not the easiest to audit. We've got a lot of if-defs here. We've got a lot of macros being thrown around. Yeah, I'm 100 lines in and I haven't even found the main function. We have exchange here. You know, it's auditable, but it's not anywhere near as easy to audit as the Musl version. And this is why a lot of people are starting to reject modernity and reject GNU in general and moving towards that Musl-based system. Now, again, that doesn't come for free, but for a simple workflow, you're not going to need glibc. And that's kind of what I'm here to prove. I've gotten Alpine Linux daily drivable with my workflow of terminals and light browsing. It's very much a small system and it doesn't need glibc. So thanks so much for checking out the video. And if you'd like to see any Linux, BSD, or free and open source software related content, just drop a comment and I'll put it in the pipeline. As always, we could not end the video without an obligatory Neofetch.